Hi, good morning to one and all. Today in this lecture we will discuss about electrochemical machining process. In this method we are using two methods, that is electrical and as well as chemical energies. By combining both these energies we are machining the workpiece or given material. Here by using electrical and chemical. Machining means removal of material. Here, the electrochemical machining process is known as ECM, is one of the newest and most useful non-traditional machining process. Belongs to electrochemical category. Okay. Next, it is the process useful to machine the metals as well as alloys, which are difficult to impossible to machine by using conventional machines. Because suppose if you machine those type of hard materials and alloys, we require special type of machine tools, and same as well as the tool is more harder than the given material. By using these conventional machineries, the tool wear increases and material removal rate will be decreases, and it will take more amount of time, and so at the time of applying forces it will more stresses will be applied on the material. These are the different limitations by using the non-conventional by using the conventional machining process. In this case of electrochemical machining process, here the tool will not touch the workpiece. For that, based on this, there is no tool wear will occur in this type of machining process. Okay, coming to working principle. In ECM, the metal removal rate takes place by electrochemical dissolution of an anodically polarized workpiece. Here, the metal removed from the workpiece by passing the electricity to the workpiece, and the workpiece and tool are immersed on the electrolyte solution. Here the electrolyte solution will pass in between the tool and workpiece. After by supplying the electric power source, here the negative terminal is given to tool and positive terminal is given to the workpiece. Here in between this tool and works we will maintain some gap. In that gap we will pass in the electrolyte solution. It will act as a conducting material. Whenever the electricity is passed through the electrolyte, here the circuit will be closed. Here what happened? Here the shape of the tool, whatever the shape of the tool, the same shape will be machined on the workpiece. We'll go to the working. Observed here I am showing two diagrams. In first one, first initial stage of ECM, that is before machining. Next, in second diagram, that is steady state of ECM. Here the left one indicates it is the workpiece, and it is the tool. It is both all immersed on the electrolyte solution, and it is a battery. Whenever we supply the battery, that is supply the power source, here the cathode is given to the tool and anode is given to the work. Due to the dissolution, here the tool shape is like one curve shape will prepared in tool. The same shape will form in the workpiece. Whatever the shape of the tool, the same it will be mirrored on the workpiece due to the passing of electrolyte solution in between the work and tool beds. in between the tool and workpiece, what happened? The electricity will pass due to this dissolution principle. If the material will be removed, how the material will be removed? We'll see in next diagram. In actual process of ECM, the cathode is tool shaped, that is mirror image of workpiece, and anode is the workpiece. Next, a gap between the workpiece and tool is in the range of 0.05 to 0.7 mm based on the type of material, and the electrolyte flows through a gap between the velocity of 30 to 60 meter per second, and it completes the electrical circuit, that is it closes, then the electricity will pass through the circuit. Next, electrolyte is pumped at high pressure of 20 kg by centimeter square, that is 1.9 megapascal in terms of pascals, and through the gap. Next, electrolyte must be circulate at a rate sufficiently high to conduct current between them to carry heat. Next, metal is removed from the workpiece by dissolution of material. Next, example, here I am showing workpiece and tool. Workpiece in yellow color, and it is the workpiece, and it is the tool. It is both the workpiece and tools should be placed in a electrolyte solution, that is NaCl plus H2O mixed with water. Here, whenever we supply the electricity, here the workpiece material used as a ferrous materials, that is iron, and tool material used as a copper. Here it consists of ferrous atom, that is 2 positive electrons. Whenever we supply the power source, the electrons from the tool to the workpiece and workpiece to the tool, it will changes, that is negative to positive and positive to negative. Here the Fe, ferrous and chloride, Fe to Fe plus plus and Cl minus will combine with each other and forms FeCl2, that is ferrous chloride, that is the metal from the workpiece, the particle metal particle from the workpiece, it will be removed from the workpiece, that is machining process, and it will combine with react with chloride Cl and forms ferrous chloride, and it will form a layer in the bottom of the tank. Next, another ferrous with OH minus, that is FeOH2, ferrous hydroxide, it will fall, and these two, it is nothing but that removal of material from the workpiece, and it forms the ferrous chloride and ferrous hydroxide. It will fall on the bottom of the water tank. Like that, the material from the workpiece will be removed. It will react with the workpiece whenever we supplying the electricity. Next, it is the schematic diagram of electrochemical machining. It consists of mainly electrolyte solution, pump, filter, next pressure gauge, flow meter, next constant feed tool, next power supply, and workpiece. It is fixed to the fixture base. Here the sky blue color indicate the electrolyte solution. Whenever we have we machine the workpiece, the electrolyte solution is separated from the reservoir through by using pump to the workpiece. Before entering to the workpiece, we use one filter to filter the any dust particles in the solution. After that we have to pressure gauge using to measure the pressure, and flow meter it is used to regulate the flow of electrolyte solution into the workpiece. Here the pipe is arranged inside the tool. Here it is the feed given by using the downside by using some mechanism. Here the tool will move in this direction. Actually it is the surface of the material. The tool will move in this direction. Due to this the material will be removed. It is the gap. This gap is the removal of material by using this method. Here the electrolyte will pass through in this direction. It will move like this. Here the power supply is given from the negative terminal is given to the tool, that is anode, the cathode, and positive terminal is given to the workpiece, that is anode. Here by using whenever we pause the electricity, the circuit will be closed. The electricity will pass through the tool from the workpiece through the electrolyte solution. Whenever passing the electricity, it will react with the uh, ferrous material with the electrolyte solution, that is chloride and hydrogen oxide, and it will form FeCl2 and FeOH2. By that the material will be removed. Like this the melting process will be completed. Next, important elements in the ECM, that is electrolyte solution, tool, workpiece, DC power supply. Next, coming to electrolyte, these are different from the metallic conductors of electricity. Generally we use copper, steel, different materials to connect the to transfer the electricity from one point to one. Here the conductor, the electrolyte solution act as a conductor. Next, in electrolytes the current is carried by the atoms or group of atoms but not by the electrons. Next, most commonly used electrolyte solutions are sodium chloride, sodium nitride, sodium hydroxide, sodium fluoride, next sodium chlorate, potassium chloride, and sulfuric acid. These are the different uh, electrolyte solutions are used in electrochemical melting process. Next, main functions of electrolyte: it carries the current between the tool and workpiece. Next, it removes the products of machining and other insoluble products from the cutting region. During the metal removal process, the insoluble particles will move to the bottom side. It will remove the particles from the working area. Next, it dissipates heat produced in the operation. Next, essential characteristics of electrolyte, that is good electrical conductivity. Next, non-toxicity and chemical stability. Next, non-corrosive property. Next, low viscosity and high specific heat. Next, coming to tool material, the most commonly tool materials are copper, brass, titanium, copper, tungsten, and stainless steels. When electrolytes is made of salts of sodium and potassium, these materials are used as a tool material. Next, the other tool materials are aluminum, graphite, bronze, platinum, and tungsten carbide. Next, coming to metal removal rate, by using Faraday's law of electrolysis, this first law, the amount of any material deposited or dissolved is proportional to its electricity passed, that is amount it depends MRR is depend mainly on the electricity passed from Faraday's second law of electrolysis. The amount of charge produced in the material is proportional to the electrochemical equivalent weight of the material. Based on the weight of the material, it will also depends. That is, the weight of the substance producing during the electrolysis process is directly proportional to the current which passes. Next, the length of time of process, the equivalent weight of the material. Next, two dissimilar metals are in contact with electrolyte and anode, losses metal cathode. These are the conditions. Next, coming to material removal rate, that is by using mathematical representation. Here m is equals to ITA by Fe is equals to mass of material dissolved. This where I is equals to current, A is equals to atomic weight, V is equals to valency of electrons. Next, F is equals to Faraday's constant, that is 96500 coulombs. Next, rho is equals to density of material. Next, T is equals to time during which electricity flows into the circuit. Next, coming to process parameters, that is power supply. Coming to power supply, here the type of direct current, that is voltage 2 to 3 to 35 volts. Coming to current 50 to 40,000 amperes. Current density, that is 0.1 ampere per mm square to 5 ampere per mm square. These are the past parameters of power supply. Next, coming to electrolyte solution, that is material, that is NaCl, sodium chloride and sodium nitrate. Next, the temperature of electrolyte should be maintained in between 20 degrees to 50 degrees. Next, flow rate, that is 20 to 120 lpm per 100 ampere current. When we use 100 amperes, the flow rate should be 20 lpm. By increasing the current, the flow rate also will be increased. Next, the pressure should be maintained in between 0.5 to 20 bar, and dilution, that is 100 grams per liter to 500 grams per liter. Next, working gap, that is 0.1 mm to 2 mm. Feed rate 0.5 mm per minute to 15 mm per minute. Electrode material, that is copper, brass, bronze. Next, surface roughness, that is 0.2 1.5 micrometer. These are the process parameters. Coming to advantages, here there is no cutting forces, therefore clamping is not required except for control motion of the workpiece. As in case of conventional machining process, high amount of forces will be developed during the machining process. For that case, we have to hold the workpiece. But in case of non-conventional machining process, in this, that is electrochemical machining, we not require any clamping devices to hold the object. It can machine configurations which is beyond the capability of conventional machining process. Next, very accurate, that is tolerance of plus or minus 0.0. It is very accurate process. Next, relatively fast. Next, can machine harder materials than the tool. Next, extremely thin materials can be easily worked without distortion. Next, tool wear is nearly absent because here the tool will not touch the workpiece. Next, better surface finishing. These are the advantages. Coming to disadvantages, it is high energy consumption because we are using electrical source. Next, non-conducting material cannot be machined because here the electricity will not pass through the non-conducting conducting materials. It is the one of the disadvantages of the chemical machining process, electrochemical machining process. Next, initial tooling can be timely and costly. Next, environmentally harmful by products. Next, coming to applications. The most common applications are, that is eSIM is high accuracy duplication, because there is no tool where it can be used repeatedly with a high degree of accuracy. Next, it is commonly used as thin walled, easily deformable and brittle material, because they would probably develop cracks with conventional machining process. Next, it is used machining of hot heat resisting alloys. Next, it is used in cutting cavities and holes in various products like machining aerospace components, turbine blades, and machining of tungsten carbide and nozzle. These are the very hard materials. These materials are machined by using electrochemical machining process by very easily. Next, any conducting material can be machined by this method. These are the it is about electrochemical machining process. Thank you.